Now we are going to go in per the schedule into the working group update. Now, I'm not sure the order of the working groups. Mustafa. Mustafa, you're up first. Oh. Yes. So we're going to start with the mobile working group update. And so just for a reminder, folks, these will be like 3 to 5 minutes. So everyone who is a working group chair, keep it quick. And we will probably actually set up a timer in a few minutes. But go ahead and take it away, and we're going to hear about mobile first.
Hello, I'm Mustafa. I'm a co-chair of the mobile working group. So just give a quick update on what we have been doing since the last community meeting. So we have completed the version 3.0 submissions and published the results. This is the first submission with the super resolution task. And we have released the MLPerf app to the press, and it's on this GitHub link, so anybody can download the app and give it a test. We have been working on what's called a website to upload the results from the app. We call it user-generated scores. I mean, so far, the results we have are just from the submission. So we're planning to get more results from users. We've been working on this for some time. So far, we only have a mechanism to push data to a Firebase database, filtering feature to the results screen, and the app authentication. We have some concern about, people changing the app and upload the results. So we added the mechanism to make sure that the results are coming from the app actually built by MLCommons. We are working on an iOS app as well, and we have been working with contractors to migrate the iOS backend from Objective-C to Swift. And one thing actually which we've been working on for some time is adding a default backend. So actually the app is not supported natively on most phones. It will probably crash if this backend is not supported. So we're trying to make it at least run on the CPU if that phone is not supported. Although that will give you not the nice results, but at least it will not crash. The other thing is actually unique to the mobile working group because we have a release of SOCs from the SOC vendors, but they don't have control over the whole pipeline. For example, OEMs will release a phone and they may not be in sync with the submission timeline. So introduce what's called SOC R&D. It allows the vendors to use an engineering device, which may not be very consistent with the rules because engineering device may be rooted and all other these things. But basically the rule is you can submit using an engineering device with your SOC. But once that SOC actually gets commercialized in a available public device, you will have to resubmit again with that available public device. So this is basically in lieu of the RDI in the main inference. Last round we introduced a super resolution EDSR model. This round we are introducing classification model. I mean, we have identified the MobileNet Edge TPU v2 large as a candidate. We're still considering it between the members of the group, and we may adopt it in MLPerf version 4. And the exciting news is two of our David Tour, which is project manager from MLCommons, and Sang-Yeon-Sun, who have been collaborating with from SNU, so National University, on the EDSR model, basically presented at the workshop for efficient learning. Our basically contribution for mobile super resolution. So that was very exciting thing. I think I have 2 minutes to go over main roadmap. So the main roadmap, basically, of course, we have the submission coming up in September, and we basically in March we want to work on a CI/CD. You have a problem, basically. We need to enable a CI/CD with physical phones. Actually, if somebody have experience with this, that would be really useful to give us your experience because we've been trying to enable this. Basically, we have an MLPerf app, and whenever there's a pull request in MLPerf app, we want to make sure this pull request is tested on physical phones. So we're trying to set up this within MLCommons. We don't have enough expertise for this, so somebody can help us. That would be great. And basically, we are working on enhanced UI UX of the MLPerf app, and we're trying to optimize core ML models that can release the app on the iOS store as well. And basically, September, actually, next September, the main milestone will be actually release the app on the Play Store and the iOS store. And hopefully, we can introduce new tasks and also probably work with Microsoft on releasing a Microsoft Windows app as well. So that will be our main goal. Thank you.
Awesome. All right, who's up next? Next one, algorithms. All right,
Hey,
take it away, Frank.
should I? No, you're sharing the slides, right?
Oh, right, yes, I'm sharing this. Oh, boy. Okay, yes, take it away.
All right. Hi, everyone. I'm Frank Schneider from the University of Tübingen in Germany. And together with George Dahl from Google, I'm one of the two chairs of the Algorithm Working Group. So just a quick reminder what the Algorithms Working Group is doing. Basically, we're interested in speeding up neural network training and doing so not by changing the hardware or the software, but by changing the algorithms that are involved in training. So specifically, that means we want to create two separate benchmarks. One for the training algorithm, so that's basically the optimizer involved in training, and the other one is basically, well, the other big benchmark that we want to build is basically the model itself. So for these two types of algorithms involved in deep learning, we want to build a benchmark. And the rest of the talk, the rest of my couple of minutes will just be about the training algorithms benchmark, as this is the one that we're focusing on right now, and we're sort of putting the model benchmark a bit on hold until we have the other one finished. So what we did last quarter was publish our first paper on arXiv, which basically motivates this training algorithm benchmarks, explains our rules, it justifies all of our design choices, and provides some experiments with some baseline submission. We also did put a lot of sort of finishing touches on our code bases, trying to fix all the bugs, implementing the workload variants, implementing baseline submission, and so on. Unfortunately, we're still not quite done with that. So what's next for us is still to finalize our competition code base. So there's still a few bugs that we need to iron out. And hopefully after that, in the next couple of weeks, we can publish or issue a call for submissions for this benchmark, for the first version of the benchmark. So in parallel, we're trying to create the blog post, the social media post, all the necessary documents and informational stuff for all the submitters, and provide support for potential submitters. In the long term, we want to publish the results of the benchmark and plan the next iteration. We already have a lot of great ideas lined up for the next iteration of the benchmark. And then hopefully we can also build the model benchmark, sort of the sibling benchmark to the training algorithm benchmark. That's everything from my side. Thanks a lot.
That's it?
Yep, that's it.
Oh, wow, okay, that was quick and brief. All right, is Diane or Sergey
Yes,
online?
this is Sergey. Can you hear me?
Yep, perfect.
Okay, thank you. Thank you, David. Hi, everyone. My name is Sergey. I am a machine learning engineer at HPE Labs, and I'm co-chairing the best practices working group together with Diane Fedema from Red Hat. So what are we trying to do? Our goal is to improve reproducibility and portability of machine learning project workloads and benchmarks. And in order to do this, we want to achieve several goals. In particular, we are proposing specifications for packaging ML projects workloads and benchmarks as OCI containers to support reproducibility. We've been developing reference implementations of these specifications that we call MLCube. and together with the ecosystem of tools, so-called reference runners for different kinds of environments to support portability. We also have, or we plan to have a different templates for bootstrapping the development of new MLCube-based projects for various languages, not only Python. And also, our goal is to provide example MLCubes that demonstrate how this all works together. Also, we've been packaging some of MLPerf benchmarks. We've been supporting MLCommons competitions, and essentially plan to promote this technology in industry and academia. Next slide, please. Yeah, so a couple updates from the last quarter. We've improved documentation. We have new unit tests for a Podman environment so that we can confirm it works. We also added several, we introduced several updates for Obtainer. So right now systems where Obtainer isn't installed and not Singularity, so those systems can also run MLCubes just fine. We've introduced several new options to CLI interface. In particular, users can now provide their specific mount options for file system artifacts so that they don't accidentally change files, for instance, input files and folders. We have a bit better support for heterogeneous HPC systems. In particular, in some of the systems, users are not allowed to run a Docker or Singularity maybe, and instead of that, administrators or the admins of those systems, they provide a special script that users are expected to use, and so we have support right now for those kinds of situations where instead of something like Singularity build, MLCube can be configured to invoke something else, some third-party script. And also the biggest update from the last quarter is essentially this last item in this list is we are now supporting so-called MLCube hashes for homogeneous and heterogeneous environments. So MLCube can confirm that it's running what it's supposed to be running. So no matter whether MLCube is distributed originally as a Docker or Singularity, right? If it's Docker, and then we run on systems where we have a Docker or Singularity, in all these hashes of the original MLCube are computed correctly, and that was pretty big deal, I think, for this quarter. Talking about next steps. Yeah, we've been writing a paper that's been almost completed, so we need to basically finalize this and publish. We plan to introduce more MLCube tutorials, meet with select partners in industry and academia, and collect their feedback, their external feedback. We plan to continue MLPerf competitions, and of course, we plan to improve documentation, which is essentially an ongoing process. Thank you.
All right, Tiny, you guys are up. Is Jeremy or Shaba online?
I am, yeah.
All right, I'm starting the timer. Yep, you're good.
Okay, great. So
4 minutes, hit it.
Got it. So just in case you don't know who we are, we focus on very small or tiny systems, generally on the order of microcontrollers, DSPs, and some small custom accelerators, kind of operating in roughly the milliwatt kind of power envelope. So next slide. So as far as what's happened last quarter, we just published results from our V1.1 round. We had a few more organizations submitting. I had 10 this time, including 7 new submitters. So it was exciting to work with a good batch of new submitters. That included some new types of hardware. We had several FPGA systems submitted, and for a total of 16 systems, and 10 of those had energy measurements as well. So we're really working hard to get the energy measurement system as smooth and low friction as possible, because that's a really key measurement for this space. And we had some useful feedback in terms of things that we can improve to make it a little bit more accessible for the next round. So we're hoping to incorporate some of that feedback for future rounds, including supporting more energy measurement hardware and just making the process a little bit easier. Next slide. So as far as what's coming up next, we have been working on a couple of new benchmarks for operating in a streaming mode. The current benchmarks all operate on it's a batch size of one, but you get the full input tensor all at once. And a lot of the systems that are appropriate for the Chinese space operate on a continuous stream of audio or sensor data or something similar, which brings up some different things to optimize. And a lot of those wind up being heavily duty cycled. So you might inference a frame every 20 milliseconds. You spend a millisecond on the computation and you go back to sleep. And so the streaming benchmarks are intended to exercise some of that type of functionality, as well as introduce an LSTM into the set of benchmarks, which we don't currently have. We are composed of a lot of small entities, small startups and a couple of academic teams with sort of limited resources, and that has resulted in kind of it being a struggle to develop new benchmarks at a good velocity. So that's been one of the things that we're working on, which on the flip side means that if you're interested in working in this space, you've got an opportunity to really make a big impact. We're always looking for volunteers to help out with development. There's a lot of really interesting problems that kind of straddle the boundaries between computation and hardware and software. It's a lot of fun to work on. So if you're interested, do please get in touch with me or my co-chair Chaba. We meet Mondays at noon Eastern time. So not too early on the West Coast. A little uncomfortable for Europe, but in general, we would love to have you join and help out. And that's what I got.
All right, Dynabench. Do we have someone? I think Rafa, are you presenting?
Yeah, David. Hello, hello everyone.
Perfect. Take it away.
Great. Hey everyone, I'm Rafael, one of the machine learning engineers working at MLCommons, and I'll be presenting Dynabench updates. Since last quarter, we're focusing on interaction, and that means we want users, be it task owners, benchmark creators, dataset creators, or dataset validators, to have a better experience and a more smooth one. So we've been working really hard on changing both the front and the back of Dynabench to get this done, and it has shown results. So can you go to the next slide, please, David? As a result of that, we've reached and we've created new communities that they've reached us, such as BabyLM, an LLM community, and we've also worked on creating new challenges for the previous communities. Those include DataPerf and the Dynamic Adversarial Data Collection community, all of which are currently running challenges. Here, I'd like to highlight the first two of them, BabyLM and the LLM community, because they're currently running very interesting benchmarks on large language models and baby language models. And we've been working really hard to get everything going on Dynabench, and we've received plenty of support from those communities to the point at which we have, I think, about 12 submissions in a couple of days for BabyLM. And LLM community, you'll hear from us in the future, but basically we're interested in beginning to create new data sets to evaluate large language models from all the different providers. Next slide, please. As a heads up, we're currently working with all of these different communities and people to create new benchmarks. Among some of them, we're working with NLP, with computer vision, with retrieval models, and all different sorts of benchmarks have been thought of to incorporate in Dynabench. to say the least, we've received lots of help, not only from academics, but also from communities this Hugging Face and Cohere that have given us support to create better suited benchmarks for the new models that are getting done day after day. So it's very interesting. Hopefully, some of you are participating with us already, and if you're not, we just want to invite you to be part of this slide in the future. Next slide, please, David. If you have a challenge, if you want to create a benchmark, if you're interested in benchmarking NLP models, computer vision models, we have a framework that allows us to get things done really easily and in a very smooth way. If so, just contact us. You can probably scan that QR code there, or just go to dynabench.org if you are interested. Thanks, everyone.
All right, perfect. Thank you very much. Next, we have the medical working group. Alex, are you all right?
Yeah, I'm here. Hi.
Hit it.
Thank you. So my name is Alex Karagiris, and I'm the co-chair for the medical working group. So for those who don't know, our group focuses on developing support and benchmarks for medical AI on real-world medical data. We have 3 goals: develop and support MedPerf, which is an open benchmarking platform for federated evaluation of medical algorithms. Second, to develop Gandalf for quick medical ML development. And finally, research and develop AI benchmarks that have clinical impact. Next slide, please. So the past 3 months have been quite busy at our group, from technical as well as organizational point of view. So finally, the paper was published at Nature Machine Intelligence this week on July 17th. It has been a very big moment for our group. It's also been a tremendous effort, taking place over the past year and a half. I would like to thank everyone involved in this, huge project. This paper would not have been possible without the strong support of MLCommons and certain organizations like Intel, Nutanix, Dana-Farber, and UPenn. I would like to thank personally Kelly, our marketing director, who has done an amazing job with promoting the paper in the media. We are already, I see a lot of traction, interest from various medtech organizations, as well as major influences like Eric Topol, who is a big guru in the medical space. So meanwhile, MedPerf is still going to be used for the FETCH challenge this year with 70 plus hospitals. And I would say the big news this year is that last month at the American Society of Clinical Oncology, they announced, that the largest working group for clinical assessment, called RANO, will carry out a large-scale retrospective clinical study to measure the postoperative, treatment outcome using AI. And for that, they're going to use MedPerf as the infrastructure. So this is great news for us. It puts us on the spot. We're aiming to deploy MedPerf in 100 hospitals, of course, depending on participation. And we're going to be working closely with partners to support this effort as it's picking up momentum. We'll have more, I would say, updates on the next community meeting. Next slide, please, David. So what's next? We have been doing a lot of great work in the technical aspects of, MedPerf. We're currently working for a data layer for MedPerf to support annotation and data preparation, interactivity. And that's part of also the RANO requirements that I described in the previous slide. We also developed an interface for OpenFL. We hope to extend it to other, FL frameworks like NVIDIA Flare in the future. There is a lot of improvements going on in the Gandalf. And finally, in parallel, we are validating various models for sustainability to our working group. And towards this end, we are kind of narrowing down to subcontracts, research grants, and specific healthcare stakeholders. But we're going to have more concrete, updates in the next community meeting. And that concludes my presentation.
Awesome. All right. That brings us to DataPerf. Praveen. All right, great. I don't have to work the slides. Come on up. You've won an opportunity in the spotlight.
Do you mind if I refresh?
That's fine. Yeah. 4 minutes. Otherwise, you will anger the technology gods.
Hi. I'm going to tell you a little bit about DataPerf. You've heard some. I'm presenting on behalf of Nusha and Lilith, who is currently the interim co-chair, and all of the DataPerf working group. What is DataPerf? We want DataPerf to be an engine for continuously improving datasets. That's what we are striving towards, and I'm going to show you what we've done so far. And we imagine in this picture this mechanical gadget where the test, model, and training, they're all moving in some synchrony. It is, might sound trivial, but this is actually flipping the standard model of what we're talking about evaluation on its head. The standard model of evaluation is those freezers are where the training and test data sit. So they're frozen, and you improve the model. That is what happens in a typical machine learning leaderboard. That's what happens in Kaggle. And that's what this results in. This results in saturation of benchmarks. So this picture that Dowie and his co-authors produced of the DynaBench working group that shows you how quickly the performance is achieved on asymptote. So the initial data sets in 2000 took like 10 years to get to asymptotic performance, human level performance. With the new benchmarks are very, very quickly getting saturated. So this model that we have been using is not good enough because it's leading to such saturation, because it's not leading the community to make progress over time. So what we propose is take the training data set and test data set out of the freezer, and they could change as it evolves. So that is the data-centric paradigm as opposed to the model-centric paradigm that we've been following. The DataPerf working group, its purpose, since 2021 it was formalized, is to build leaderboards for data and data-centric algorithms. So if you think about Kaggle and the typical machine learning leaderboards as leaderboards for models, we want to build leaderboards for data. Specifically, our goal that we were working intensely in the last year and a half was to launch half a dozen different data-centric challenges and build a community around this idea of data benchmarking. And we believe that we have organized 4 or 5 workshops at NeurIPS, ICML, top machine learning conferences on DataPerf and data benchmarking. And the fourth one, the last one, is coming up right now in Hawaii at ICML. We'll tell you a little bit about it. So at this point, we feel like we've gotten this community epicenter, and we have launched these challenges. Let me tell you about some of the challenges. There are these different data-centric tasks, like data cleaning and valuing data. And there are these different domains, like vision and speech and NLP. And at the intersection of these, we found these 5 challenges that we launched. We launched these challenges on March 30th, and we closed the challenges on July 1st. I'd like to thank Kelly for helping us spread the word about these challenges across the media. We got a total of 79 submissions across 5 challenges. The 5th challenge, adversarial enabler, that Peter gently hinted at, is actually being launched at AACL. They're following a slightly different model of getting participation in these challenges. What we found, the results are still hot off the press. We don't quite have the final numbers, are still being crunched by the challenge organizers. But this is just kind of the engagement statistics. Most of the participants were grad students and some were startups. The challenge organizers were mostly faculty and big companies and startups. The winners will be announced at July 29th. Our main track at this point in time to round this up is to make sure that we publish and capitalize the impact of these challenges that we've had so far, figure out what next. So what's next? Difficulties that we encountered in the first launch. Engagement was a challenge. It was difficult to get a lot of people to participate. We really knocked on the doors. And at the end of the day, most of the participation we got was from a very strong participation from students, grad students, and academic institutions. Low to medium participation from startups, and none with big companies. So at this point in time, we're rethinking our approach to DataPerf 2.0, and there are a bunch of different dimensions of how we want to go about. One idea that I want to point out is we want to go all in on one important data set and help that. Join the working group. We are having a roundtable about data and data-related issues at 12:45 today. Come join and talk to us more about it. Thank you.
All right. Perfect. We've got inference next. Okay, hold on. So we would like Kurt to come up, and so inference folks, we're going to put you. Where did Kurt's slides?
It's just before that. Sorry.
I see. You put them out of order. Okay.
Hold on.
All right, Kurt. No. Come on up. Okay, so we're doing this out of order. So Kurt is the chair of our data sets group, and so take it away and give us a run through.
Hi, as David said, I'm chair of the group. Let me tell you a little bit about it. It's been running for a while, but the purpose of this working group is to support the very bottom of the stack. Let's build data sets, all of the general tooling that everybody needs to do that. And in particular, you know, as we see with a lot of the saturation, you see data sets are what better data sets are what are going to drive, you know, innovation over the next 5 to 10 years in a way that you can't do with just better model architecture. So one of our specific mission, our goals are we want to create, just outright create useful data sets and be able to, and that, I mean, useful meaning they're impactful from a performance perspective, they're unencumbered by licensing difficulties, and we want to make them available, so we have an effort in hosting as well, eventually, and partnering with that. And because, you know, you don't want just billion-dollar companies to be able to do this, everybody needs to be able to access it. As we saw with the release of the leak of Llama, once everybody got their hands on it, innovation started exploding, and that's the kind of innovation we want to stimulate. So in addition to our more previous mission of just creating data sets, we are now pivoting a little bit to focusing at least partially on data set tool creation. Let's build the tools that make it easier for people to create data sets in the ML space. And then there's a new task force that Peter talked about that's loading the croissant, which is an innovation around common data and metadata formats. So one of our biggest efforts in this tool creation is this source of truth dataset service. So the idea is to be able to scale up both the size of data sets and the ability for people, the number of people who are collaborating. And we do this through like a Git for data, which means we want to be able to support, you know, commits. We want to be able to support multiple people building things together. That means branches, it means forks, it means versioning, all those things that can be done asynchronously and, you know, and not, you know, be limited to a single small org. And also, we're hoping that we're going to be able to support more sophisticated metadata like what Croissant represents, but also the fact that not just data set level, but perhaps data item level as well. And then given all of that, we want to be able to index it so that it can be easily found and filtered and shareable. So what have we been doing? Real quickly, recent progress in the world of data sets. There's the speech Wikimedia data set, which is 1,500 hours from, you know, the wiki data of different, different speech files. There's a supervised and an unsupervised data set. We have released the supervised previously. We've now made an improvement, added some, fixed some bugs and made it easier to use. And unsupervised, we're at the edge of releasing. We've got something that's fully processed, and we're just tweaking it and fixing bugs to make it available. And there's a paper. If you go to the DMLR workshop next week at ICML, you can see we've submitted got a paper accepted to talk about that. People speech, it's out there. You can use it right now. Now we're focused on making it more available, and that's tooling around making Git run faster. In the source of truth public server, we have hardware in place. We've got the people speech data set on it, and we started work on the software stack. And as far as licensing, we've got a side project we're working with some grad students from Harvard and MIT to build. They're building a lovely provenance metadata tooling infrastructure. They're going to have 2,000 data sets with clean, fine-grained licensing information, as well as task applicability and subject matter. And then finally, as Peter talked about, we have an initial design complete for Croissant, and testing and software and the release process is already done. So where are we going? We're going to keep push out the data sets. We're going to release the first POC of our software stack for the server, and then integrate all that licensing and Croissant data format infrastructure into our overall server architecture. And if you're interested, you can reach out to me or Peter, and we'd love to have you at weekly meetings, and you can join our Google group. Thanks.
Awesome. Thank you so much. Again, you know, I sort of think of the data sets working group as we want to build the digital library of Alexandria for data sets. So if that's intriguing, come talk to Kurt later or join the working group. Now we are on to inference. I don't know, Miro or Michelle or one of you online? Sounds like a no. All right, great. I used to chair this group, so I can make some stuff up. So the inference working group focuses on MLPerf training, MLPerf inference. This is how do we deploy neural networks. The key thing we have here is the MLPerf inference benchmarks. We're having submissions shortly. For those who don't recall, MLPerf inference submission is in Q1 and Q3. The deadline is coming up in, I want to say, like 3 or 4 weeks for MLPerf inference. Also, Miro Hodak has recently taken over and volunteered to serve as work group chair. We're really excited by that. Is Miro in your group, Ashley? Oh, we have cross-group. So we've got our hooks into multiple groups at AMD. But Miro used to be with Lenovo and had worked on a lot of MLPerf submissions there. And it's been great to add him to the team. Michelle has also been doing a ton on leading. Updates from last quarter. So we are introducing an LLM benchmark for inference. It is not quite the same as GPT-3 on training, right? So for training, we went for the biggest, most extreme model we could find within reason. That reason being we don't want to spend too much money for people who submit. But in general, in the inference working group, I think there's a little bit more of a focus on smaller models. So we're using GPT-J, which is a 6 billion parameter model. We also have an inference version of our second generation recommendation model. So those are the two task forces going on. We've got DLRM v2 is sort of owned and executed by MLCommons with supervision from Google. And then the LLM task force was sort of jointly led by Google and Intel. Oh, Miro, you're here. Okay, so I'm going to just get to the end of this slide and then you can talk about the next piece. We also have the open source CK MLPerf automation platform. So that's really designed around the idea of how can we make, Grigori led this, how can we really automate submitting to MLPerf? If you want to submit 1,000 MLPerf inference measurements, how you go about doing that as opposed to have it be very manual. And so I think there's a call for participation within the CK community to do submission for this round of inference. All right, Miro, you want to talk about what's next?
Oh, absolutely. All right, so thanks for sort of taking those two first slides. So yes, we have 3.1 coming up very shortly. We have about it's August 4th, and there will be a review period, and August 30th will be sort of the big days, right? We have what's sort of coming up is for version 4.0 next year, right? We definitely want to work on the enhancing our LLM benchmark. By the way, the 3.1 we're going to have a GPT-J 6B, so we sort of want to sort of continue evolve that. Look into the ways how we can take it forward, make it bigger, potentially have 2 or 1. That's all up to the discussion. That's all sort of what task force will be working on. We also want to introduce a new benchmark, where sort of our leading contender right now is Stable Diffusion, Automotive or GNN. We also want to sort of improvement in networking characterization. What it really means is that right now our server, we have server scenario in which we have a load-gen process sending queries to load-gen process query within the server. What we want to do, we want to replace it so that we have more realistic scenario where server is actually a two server setup. We right now have that already working, but going forward, we want to integrate it as the first-class citizen in our suite. So top 2-3 challenges. We really have benchmark are increasing complexity, especially with large language models. We can see that sort of development. David says how much time they spend in training. Inference is different. We don't need so much training time, but we still need to make sure that sort of model behaves correctly. We need to make sure that models are fine-tuned, and you need to have. We need to deal with the data and things that come with that. That also leads to sort of development timelines being extended. And we're going to come very close with new benchmark. We would need to make a tough decision of retiring certain benchmarks, and so that we can have new ones. And we don't have, there's not infinite number of benchmarks. We kept it to 10. we kept the total number to 10. So top community asks, we definitely, as I said, we'll the task force, we're going to have especially LLM task force and the task force for the new models. This is something that we need help with. So please, if you are interested and if you can help, please sign up for the task force. We also need sort of, this is a collaborative effort. So we'll sort of need more contributions from other organizations. Please contribute, right? And of course, very importantly, the main participation is, of course, within working group where all of these things are being discussed in details, and of course, make submissions if you can.
All right, perfect. Training working group. Who do we have? Ritika or yeah, I guess Eric's on vacation. So Ritika, are you here?
Hey David, yeah, I'm online.
All right, let's take it away. And
Right.
you get the timer as well.
Sure. So training working group, we develop and conduct the MLPerf training benchmarks, and our primary goal is to spur hardware and software innovation of ML platforms by means of training, by benchmarking training performance. So let me take you to the updates from the last quarter. David, if you could take me to the next slide, please. Right. So last one on June 27th, we published training v3.0 results. And the highlight of this round was we had 2 new benchmarks. We had a large language model, GPT-3 billion model, and we got to see 3 submitters participate on that benchmark. And then we also had DLRM, DCN v2 on a multi-hot data set, where we saw 5 submitters. And hopefully expecting more submissions on these very hot workloads in the future rounds. Besides the summit, we also had more than 259 results across 16 submitters, and there were 3 first-time submitters as well. Some other developments in the working group, like we have identified MLCommons Seagate bucket to host the MLPerf datasets, such as the large language model checkpoints and dataset, and the dataset that will be used for the stable diffusion benchmark, which I'll talk about shortly. And I know many people in the community have been trying to access the dataset and the checkpoints, and now in the READMEs, you'll soon be able to find a Seagate public location where you'll be able to easily download the checkpoint and datasets for the LLM model, and hopefully more other models in the future. The other exciting development in the working group is that last week we are now benchmark code complete for a new text-to-image benchmark, which is a stable diffusion v2.0 model, where the image size is 512 by 512, which means the unit space is 64 by 64. And it will train on a subset of Lion 400 million data set. So the subset is around 6.1 million images, and the validation will be on the COCO 2014 data set. And we are looking at something like a target accuracy, a combined target accuracy of where we look at FID and CLIP scores. Other exciting development is the power methodology spec for training is near complete. And in the next few weeks, we will be taking it through the logging and adding the required logging checks to make submitters who want to measure power easier, the process easy for them. So what's going to happen in the next quarter? So October 6th is the submission for training v3.1. And like I said, the new things would be, there is one new benchmark, like a Gen AI benchmark, stable diffusion, very excited for that. And then, of course, listening to the demands from the community, we are also going to incorporate power measurements in the upcoming round. And then we have multiple task force. We're doing exciting things with trying to complete benchmarks for the roadmap for the 2024 roadmap. And so we have an automotive task force, where Rod is developing a point pillars benchmark, which will be training on the Waymo dataset. And then we also have a GNN benchmark, RGAT, on the IGB dataset. And as part of the process, we always take a look at our roadmap to think if we want to update some benchmarks or replace some old outdated benchmarks with these new benchmarks. So those would be some interesting discussions to look out for in the working group in the coming quarter. The link is there to join the working group, come join us. We meet every Thursday at 8:30 a.m. Pacific time, and look forward to seeing more and more participation in MLPerf training.
And just, I get to editorialize a little bit. I want to just say, like, one of the things that I've been really impressed by is just the velocity of things within, like, both training and inference. Like, adding in GPT-3 was certainly not easy. Adding in stable diffusion, also not easy. The Lion data set, is a very challenging data set to work with because of the licensing issues. And so it just really is a big effort to land all of this stuff. And there's a lot of heavy lifting going on here. I'm also personally very excited by the power measurement. So, and one thing to mention, we'll hear about this later from the power folks, but it actually works on both cloud and on-prem data centers. And that cloud part is actually especially novel. All right, HPC, Andreas, you are up.
All right. Hi, everyone. Hello. I'm Andreas Prodromou. I'm one of the two co-chairs of HPC, along with Murali and Mani. Here's some information here if you want to get involved. But as an overview, the goal of the HPC working group is to benchmark the performance of HPC applications on supercomputer systems. We published the MLPerf HPC benchmark suite on various conferences, and we throw tutorials and all that. Our goals is to keep adding more benchmarks. A big goal we have, especially in these coming rounds, is to increase our popularity, the level of competition in the benchmark, and the level of interest in general. Plus, we have more metrics. We have the throughput metric that we added in the last round, which essentially rewards systems with large scale. So if anyone has access to a supercomputer, an HPC system, we would love to see you submit. Some updates as we work towards the V3.0 submission round, which is also due on October 6th. First of all, we took some steps to attract more submitters. We specifically made it easier to submit, and we focused a lot on maximizing the return on investment of a submitter. We also are adding power consumption measurements similar to MLPerf training, and we're very excited about that. More than that, we added, in my opinion, a very exciting new benchmark in the protein folding space, the OpenFold, which is the open version of AlphaFold 2. And we're now focusing on outreach. Some of the rules we updated to make it easier for submissions is, first, we are now excluding data movement from the time score. It used to be that everything was included in the score, but now you're allowed to move your data on your nodes, then start your timer, and then run the benchmark. And we also renamed our benchmarks to make it all cleaner and clearer to understand for the average audience member. What's coming up next in terms of outreach? We are doing a birds of a feather session. We're also reaching out to various HPC facilities and vendors. And the working group has created outreach assets that anyone here is welcome to use and share with your own networks to increase participation to our submission. We're also doing tutorial sessions wherever we can, hands-on sessions with supercomputers such as Perlmutter, and there have been tutorials on various AI accelerators. All right, so a few dates for HPC v3.0. The benchmark froze on June 12th. Everything is ready for submission, and the deadline is October 6th. We'd love to see as many submitters as possible. Thank you very much.
Oh, sweet. All right. Great. So now we've got power. That's either Sachin or Tejas, who are probably online. Do we have a Sachin or a Tejas online?
Sachin, do you want to go?
Uh-oh.
Yeah, I'm here. I can
All
speak,
right.
and then Tejas, you can jump in. So,
All right. You got 4 minutes.
yeah,
So give
I think
us.
yeah. So given that we just got these slides in just over the last 1 hour in, we've just made a copy of what we presented last time, and then I'll verbally speak to. I think there's been discussion about power in HPC and training, so I'll speak to that. So what we are is a best practices working group. So we are not a benchmarking group, right? So people confuse us with being benchmarking, but we are not. We support or work with other benchmarking working groups, and our objective is to ensure that energy efficiency is a first class metric like perf, right? So in MLCommons, right, we have MLperf attached to it, but it's basically energy efficiency has to go along with perf, right? So we started back in like 2019. There were some sketchy documents around sketches around what we should do for power and mobile, but eventually we adopted for inference, data center and edge, which has been, I think this is the sixth upcoming one would be the sixth submission for power and inference and edge. And then Tiny has also independently come up with their own methodology, which follows flow, which follows the same methodology where we are tracking, energy within the window where performance is measured. So jumping quickly, our key OKR for 2023, when we discussed with David and others back last year, was to enable power and MLperf HPC and training. And over the last, let's say 6-7 months, we've had a task force where we've had participants from both training and HPC come in and really work towards a common way of having consistent approach to submitting power so that energy efficiency can be tracked. And it's particularly complicated for distributed systems. So this time I just have like 3 or 4 minutes, but I think hopefully in the next community meeting, we can get maybe a few more minutes and then we can talk a little bit more about how we went about doing the disaggregated methodology. So we're well on target, and as Ritika and Andrea's talked from on behalf of the training and HPC working groups, we have worked well enough that we're confident to deliver power in October 2023 submissions. So I think that's been a great lift on part of everybody in the task force that worked with a common purpose. And then, as David said, we had to consider a methodology because we have enterprise and OEMs and we have cloud and we have supercomputers. All of them have to submit power, and we wanted to come up with a consistent methodology, which we have done, right? So it's not perfect, but it is good that we can have a starting submission. So, and then for inference, we made improvements. Every submission there are some issues that come about, and then we try to fix them. So we've been doing that. But I was talking to Tejas that we need to think through about having more aspects around energy efficiency in inference, considering real world scenarios. But that would be some a discussion for the future. So for this round, I think we've just done incremental changes to take into account whatever issues we encountered to make the submission smoother. And for inference, we've also been seeing a lot of submitters come in and submit, new submitters, startups, newer companies. So it's great to see the community participation in inference power submissions. Tejas, you want to add anything more?
No, you covered it.
Okay. So David, next slide. The next slide is more on just call for action. We've got, please join us. There's a lot of good work happening, but we definitely need more people participating, diverse ideas to test out and figure out what we should do forward looking, right? Especially for inference, for data center and edge. And then we have 2 meetups weekly. We have one which is our standard Power Working Group meetup, which happens on every Tuesday at 3 p.m. It's presently focused on inference, like I said, but but going forward as HPC and training become, they start doing submissions, we'll consider issues and improvements to the methodology in that meeting. And then on Wednesdays at 8:30 a.m. Pacific time, there is a task force for power for in HPC and training. So please do join us. Reach out to us. You can write to Power or reach out to Tejas or me, and we'll get you. So we're looking forward to more participation from the community.
Absolutely. Thank you guys very much. I want to just, brief editorial. One of the things that's been going on in the industry is there's a lot of attention being paid to the energy emissions due to ML. There's a lot of focus on how computing can be green. And one of the things that is especially challenging is there's not really a good industry standard and consistent way to actually measure the power consumption for training at all. And so one of the things that we are very interested in doing is the MLPerf power measurement for training in HPC will give us the ability to do that. And so giving us the ability to actually accurately in a consistent way quantify that really does elevate the discussion and helps us to drive everything forward. So this is a great example of how, just the work here can really drive the whole industry forward. All right, next is benchmark infrastructure. Shin, you wanna, or Kong Tao, whoever's gonna present, come on up to the top, and we've got your slides waiting. All right, take it away. You've got a few minutes.
Hi everyone, I'm Kong Tao, and I'm a co-chair of the Benchmark Infrastructure Working Group with Xingyuan. The purpose of our group is to develop infrastructures and tools for other groups to use. For example, we develop the submission checkers and the logging libraries and the result summarizers. We also develop and operate the submission service, the website. Last quarter, we support the training 3.0 submissions. We develop logging systems and new submission checkers for that. We also create a new system for the storage submissions, which is new and what was the first time for the last quarter. We are also trying to work with power submissions for power for training and HPCs. This quarter, our highest priority goals is to improve our submission systems for storage, as well as support the power submissions for training and HPC. We will develop new submission checkers and also new logging libraries for them. Some of the relatively lower priority goals includes developing authentication systems for all the submitters so that the submission system has more securities, and also further automate the submission systems, especially for the result reviews and the code reviews. And other things include other infrastructure cleanups and documentations and CI/CDs and releasing processes. If you are interested in our work, you are welcome to contact me to join our working group. And if there is any other future requests from other working groups, please send that to me as well. Thank you.
Who's next? Science working group. Do we have Jeffrey, Yuri, or Jayan online?
Yeah, I'm here.
All right, take it away. You got 4 minutes.
Fine. So this is an old basic slide, which just says we're trying to deliver on MLCommons' general mission in the area of science and engineering research. And a critical feature of our working group is that we're as much focused or more focused on scientific discovery metrics rather than performance metrics. And there are lots and lots of scientific domains, and so there are actually potentially a lot of possible benchmarks we can develop. And we also have quite a lot of interest within the working group on using fair metadata and getting reproducible answers. And maybe another, general point is that we find our benchmarks are used as much in education as in research because they provide well-documented examples. Next slide. So here is what we're doing. So David mentioned at the beginning, we released finally our first benchmarks, which cover satellite imagery, material science, drug discovery, and earthquake forecasting. This is unusual for MLCommons in that it's only got an open division and it has rolling submissions. And as I mentioned, scientific discovery is the main metric. We're actually working on 3 white papers. The first one is mainly a focus on how to do fair issues properly. Another one on more related to power and efficiency, benchmarking data. And another is just how to do benchmarking. However, most of our work this quarter has been on planning. We spent lots of sessions on deciding the right balance between supporting the current benchmarks, new benchmarks, and other things. And that's in the next slide. Okay. So we know that they're going to be, we just issued a public announcement. We have 2 submissions we're expecting soon, and we're looking for more. As I said last time, we have several new benchmarks being presented to the group, but we've not made a strong decision, a firm decision on any of them yet. I hope that this quarter we'll complete the first one of the white papers on fair metadata. When I go to conferences these days, they only talk about one issue, namely foundation models for science. And so we've had some discussions on those and what they imply for benchmarking and in terms of data set and models. And to show you why it's not quite so obvious what to do is that when I say everybody talks about foundation models, they actually define them in very different ways. So let's take a project I'm working on, and the word GPT just means foundation model. So if we look at an earthquake foundation model, one person would have told me to fine-tune ChatGPT on something to do with earthquakes. There is a huge DOE project, probably, which is going to develop science GPT with pouring a huge amount of science data at a exascale machine. So we might want to fine-tune that. Perhaps, at least what I originally thought we might want to do is to look at earthquake data as an example of a particular time series. So you might want to do a foundation model for time series, or maybe a foundation model for geospatial time series. And the final possibility, well, there's a lot of regions of the world where you have earthquake data: Turkey, Haiti, Southern California, Northern California. So you could pre-train on all the world's data and lots of simulated data, and then fine-tune on particular regions. However, all of them need probably the same basic data. So we're trying to understand what this means. Thank you.
Perfect. Thank you very much. So just in brief summary, how can we think about foundation models for data that's not the standard, text, vision, audio? Very, very interesting ideas. Lots of promise for science. All right, MLPerf storage showcase. So this is a little bit longer. We're going to be talking about the MLPerf storage benchmark, which is now open for submissions. We have Curtis, who is the benchmark chair, joining us live and in person. And that means I get to take a break for 15 minutes. Yeah.
Okay. Good morning. So, MLPerf storage, they wanted me to do a showcase, meaning a little bit longer background on what it is and why it was started and all that. So the context for it. So I figured I'd do the superhero thing, the origin story. David has impressed upon me that it's all about research and optimization. And so there's 2 things that we in storage need to do. So I'm a storage person by trade. I'll introduce the other co-chairs in the next slide. but covering both of those, research into the storage support for AI ML workloads, and also allowing researchers and vendors to optimize storage to support that community. So that's sort of the first thing that started, the first impetus for the working group. Data models, accelerated storage, and networking, sort of the 5 basic pieces of the ecosystem that make up AI ML. MLPerf at the time that we started really only touched models and accelerators. It's since started to expand deeply into data, but storage was missing. So we were starting to say, okay, figure out what's required. You'll need to see this a couple times. You can't measure it, you can't improve it, so got to measure it. Okay, so the people involved. There are 4 co-chairs. I'm one of them. We have a assistant professor of computer science, so there's an academic bent. 2 people from industry, me and Janu, and a guy from the Argonne National Lab, so a DOE physicist. I call this the getting stuff done subgroup of the overall working group because Janu handles some scripting at the high level, and WeHo handles an application called DLIO that actually emulates the workload that ML training applies to storage. We'll get to that in a second. I help out. So the working group charter. Develop a benchmark suite that applies the same workload to a storage system as running an MLPerf training would for different AI stacks, etc. So the important thing here from our point of view is that we want to emphasize the correlation. What MLPerf training runs, the training aspect is MLPerf training is focused on the model and the accelerator, the GPU. We want to mimic exactly the same storage workload as MLPerf training would impose on the storage, but we want to do that without the GPUs, without the model, without the data, without having to deeply understand how AI ML works. This is a benchmark that's focused on storage practitioners and on end customers who say, oh, I have a problem. I know from MLPerf training how many accelerators I need. I need to know what kind of storage I need to keep those accelerators fed. So that correlation between the two is one of the characteristics that we wanted very much to get out of this. I mentioned some of the other things that no GPUs, no deep AI ML knowledge, right? I can testify because I'm a storage person, I learn all the AI things as we're walking along the path here. This is our first submission round, so we've got the infrastructure set up for, we understand the problem now. I'll tell you more about how we're solving it of benchmarking storage systems. We are coming up the ramp on keeping up with training. The velocity of the MLPerf training group is pretty high, and so they're changing the models that they use, and we're catching up to them, right? Bringing those the workload that the new models, DLRM-C and RC, and whatever, the latest one, that applies to storage. Anyway, we're catching up. Right, there are 2 explicit things. One, storage vendors, if you're in the market to purchase storage, then the storage vendors should be running benchmarks that tell you how well their product performs on the AI tasks that you want to perform. Working for a storage vendor, that's one of the explicit things that the storage people who don't generally know much about AI need to be able to do to support the community. But then also storage vendors to optimize their product for the workloads that come from AI. Because otherwise, storage people operate on benchmarks. You get IOR 500 from the HPC community, and you optimize that, and that gets you more customers in that market. So, emulation. We looked at a lot of different approaches and ended up with emulating the workload that MLPerf training applies to storage. So, to take a specific example, PyTorch versus TensorFlow. So PyTorch, in an image classification type of benchmark, is going to store 1 JPEG per file in a million files in a relatively deep directory tree. TensorFlow, on the other hand, is going to have a couple of thousand files with 1,000 images per file. Those are extremely different workloads from a storage perspective. And because we also had this goal of not requiring GPUs or AI knowledge, we needed to emulate it. To say we need a program that will apply the same workload to the storage. So we ran across an application out there called DLIO, Deep Learning IO. It's an open source project written by Hui Ho. He's the primary author at Argonne National Lab. And so it generates a synthetic data set. It's all random data at this point, so that compression and dedupe in the storage system don't give those vendors an advantage. But it has the same statistical characteristics as the actual data sets stored on storage. We're using just a simple sleep to emulate the computation time in the GPU so we don't care what the data is, we're going to sleep. That's sufficient for us to, you can see there's some traces here on the right. We have validated that the synthesized IO workloads match well enough for practical purposes the actual IO workloads. So this is a eBPF traces inside the Linux kernel on the IO, the block IO. So emulation is the path we've been going down with synthetic data. So I went through some of that. Some people have asked, okay, where do you get the data? We don't have licensing questions in our working group because we're just going to synthesize files of the appropriate statistical characteristics full of random numbers. Benchmark submission is now open because there's, I'll get to more of this in a second. There is so much random variation, well, what I would consider random variation. The practitioners in AI do what they want to do. I don't want to call them cats, but they're untrainable. The number of people that use PyTorch versus TensorFlow versus 8 of the other different frameworks, each one has its own data storage format. So now Croissant, we have to go figure out, because we want to support the overall mission of MLCommons, so we want to support Croissant. So we have to figure out what that means.
Put it on the roadmap.
Absolutely. So one of the operational challenge for us is that some of the MLPerf training benchmarks run under PyTorch and some run under TensorFlow, for example. And we would prefer to be able to run the same benchmark under PyTorch or TensorFlow, because we're trying to illustrate to the AI community and everyone that there are differences in the workload. And so what might be convenient and easy on your laptop or on a small system scale very differently when you have a lot of data. I have a nice analogy that I like that sort of sheds light on it for people who aren't into storage particularly. Data is similar to water. It has a phase change. Data, when you have steam, it moves through piping really easily. If you have water, you have to have some pumps, but it moves through piping fairly easily. Data can also turn into ice, and it doesn't move through pipes no matter how hard you push. You need a different architecture. And so that, for example, ice crushers and conveyor belts. The point is that steam is gigabytes, water is terabytes, and ice is petabytes. When you get to the petabyte scale, everything's different. Okay, so the submission window is open. We currently have, I think the latest count was like 6 groups planning to submit, 4 storage vendors, accelerator group vendor, and a research group. Argonne National Lab, by the way, is a wonderful resource because they have one of everything in terms of accelerators, Cerberus, and just everything. Current working group activities. In order to get the benchmark out at the beginning, we focused on the simple case of a single data set with a simulated set of GPUs running on a single computer. So that's not typically, so we could go, we have results because the storage systems that people are putting underneath this benchmark are, for example, all flash. And so they say, oh, let's put 128 simulated GPUs on one high-end machine. Well, that doesn't work in reality. But it's sufficient to show the performance of the storage. What we need to get to is the next thing we're going to work on is distributed training. So that's a single data set on shared storage with a simulated number of computers, each with a rational number of accelerators on them, and show what the storage system can support in terms of a distributed training environment. And then, of course, keeping up with MLPerf training in terms of the number of different workloads. So, issues and asks. We used to have a guy who showed up from one of the startup accelerator vendors, and so that was really informative because he said, you know, he kept telling us that Thaddeus, he's a wonderful guy, works for Tenstorm. NVIDIA has a particular view of the world, which is really important because they're the dominant vendor. But there are these other vendors that also have different views of the world, and making sure that we're accommodating them in terms of the benchmark and allowing them to show their advantages where they are different from NVIDIA, for example. It's harder because you have these very different architectures. Number of GPUs attached to a node that model doesn't apply to Cerberus. They have something at the other end of an Ethernet cable, and you don't know or particularly care what's inside their box, other than it does screaming fast training, right? So, you know, that'd help us to have more representative different architectures for accelerators to make sure that we're producing the right benchmarks. Actually, we really like some help from the infrastructure group. We do appreciate the help on the open submission window, right? But there's also we want to collect the computation time. Since we're using sleep, we want to collect the computation time for a particular workload on a particular make and model of accelerator, and so we can use that sleep in our benchmark. We want the MLPerf training benchmark submissions to include the specific number we want. Then we can just leverage that. So there's some tie-ins we're looking for. One of the bigger problems for us is just the amount of variability inside the practitioners out in the field. They all do things that are appropriate for them and they think are the best idea, but us knowing what is sort of the mainstream de facto common structure that we can then benchmark to is a good example of something difficult. And then the last slide, something that's a much harder thing, but I figured I'd throw it in here because it's going to be a major challenge for our working group. Data prep. It's the there was a study, a paper published by Meta in about 4 years, 2019, I think. But their claim was that data prep takes about 50% of the total electricity watts consumed. So training proper and the power-hungry GPUs are a piece of it, but just the data prep that they had to do was about half-ish. Yeah, no, it was like very eye-opening for me as well. It's like, even though I don't know that much about AI, it's like, wow, okay. Yeah, that's all just CPU, normal sorts of processing, image manipulation processing, not particularly GPU-based. So from our point of view, we would like to, from the storage working group perspective, we would like to be able to simulate the load imposed on storage from that piece of the overall workflow in an AI project. But given that this is very task specific and practitioner specific, having the community develop some guidelines, some middle of the road statements about what data prep is, a consensus definition of what it is, if you will, would help us a lot, because then we could start to build a model around how we emulate that load on the storage. So given this was a showcase rather than a status, any questions for me before I jump off the stage?
Yes.
Please.
So are you familiar with Flynn's taxonomy?
No.
You should take a look at it.
Okay.
You mentioned data compute and other balances.
Sure.
Can we discuss that later today, please?
Sure.
Thank you.
Okay. Anything else?
Is that the paper from ISCA last year, 2022?
The one that I quoted?
Yeah, the one that you're showing on the screen right now.
No, it was
there was a meta paper which also talked about the cost of doing ETL and the data pre-processing, which actually consumes a fair amount of computation. So
yes.
Yeah, at some point, whenever the benchmark progresses, I think we can also apply, if you want to actually track the energy consumption of the storage and extraction, transform, load, all of those. If that's covered,
yes,
we should think about that. So.
Yes, that's a good point too. That yes, eventually, the crawl, walk, run. The power consumption of storage systems can be significant as well. And so if you're talking about the whole life cycle for an ML environment, there are separate projects to monitor the power consumption of storage in an HPC kind of environment. This working group has not yet taken up or even glanced at.
Eventually.
Trying to bring those together. But yes, it absolutely is part of the project eventually.
Yep. Sounds good.
Thanks.
Yeah, I have a question. So your metric is just like a speed, like samples per second. I see with have some minimum on the accelerator utilization, right?
Yes.
So I'm kind of wondering how you think through this. So in terms of data loading speed, generally once your I/O system is fast enough to keep the accelerator busy, you're kind of happy. You don't really care about the data loading, the storage being faster, right? Being faster than that might be more expensive without actually adding any value. So just faster is not always better in that case, right? So how are you guys thinking about that? Or
yeah, so the market has been conditioned by some of the vendors, the early movers and the vendors, like Pure, not to denigrate them, but they were one of the early movers. So they set this expectation that AI all flash, end of story. And you're right that for image benchmarks, for example, we're using on an A100, I believe it's 1.7 seconds worth of compute time on a batch of images. Well, that gives you 1.7 seconds to collect all of the other images for the next batch in main system memory. I'm ignoring GPU direct storage for the moment, right? And so that double buffering, you've got a certain budget for collecting all those. You don't need an all flash solution for that until you're talking about really large scales and small data sets, and then the IO density gets high. So yes, there is this interesting relationship that you can pay a lot of money more than you need to for a storage system, depending on your workload. Now, if your workload is a recommender, where the amount of computation per byte of data is very low, you got to stream the heck out of that data through there. There you're talking about really needing GPU direct storage, the RDMA all the way through. So there's this complex set of trade-offs. That's why we're trying to stick very closely to the MLPerf training benchmarks and their workload, rather than branch out and do something unique, because people wouldn't know how to compare it. Does that make sense? Does that answer your question?
Partially.
Well, if I'm happy to refine. I mean, he hasn't thrown me off the stage yet.
Well, we could.
Okay. I'd be happy to sit down.
No, I mean, we are at time. I mean, anyways, I think one of the just sort of, again, setting context here for folks around MLPerf storage, right? The MLPerf training benchmarks really start with data in host storage, right? Or is it host memory?
Storage.
Yeah, host storage, right? So that is in node local storage, right? But originally when training started out, that's what they did, and part of that was we didn't want to be measuring how you move data across a network to get into your local compute nodes, right? Now, it turns out the HPC folks did specifically want to do that, and they set the starting point at being, where do we have where the starting point is data on permanent global storage, right? Which is really at the start of the problem that you would actually have. And now over time, the HPC folks have changed their rules to be more consistent with training, but this means that we actually have an increased focus on how do you get that data from your permanent storage into the local node, which is really one of the areas that storage drills into, and how do you balance that appropriately? Like one of the motivations for this was, first of all, Debo Dutta, who's at Nutanix, was talking to me about this, and I had talked to some other OEMs who had mentioned that they had seen customers where an improper configuration of storage had led to compute clusters being, 25, 30% utilized, right? And so what that meant is there's a lot of lack of knowledge, there's a lot of opportunities to help drive performance. So I'm very excited about this. It'll bring some new folks into the MLPerf community. And so if you're at all interested in storage, please get involved. And at that point, we've got a lunch break. So I think that concludes the broadcasted portion of the day. So for those who are here, we're going to have 2 breakout sessions, one on value, one on a data roundtable. For those who are joining us remotely, you can do as you see fit. The afternoon, evening, morning, whatever time it is all up to you. The recording will eventually get posted on YouTube. And thank you so much for taking the time to join us.